Okay. Oh shoot, I need to share screen, right?
Yeah.
Okay. God, we're just gonna see what did I do. Okay. Okay, so if you guys came to last week Wednesday, you saw intro to web hacking. And now today you're gonna see how to inject code into the website.
Wait, we need to share the Zoom link so they can join it.
Who's they?
Rory and like Jason. Jason, you're doing a demo, right? Okay.
Okay. No one's saying anything. So copy invite link. Oh
God.
No. I can't see anything I'm doing.
What are you doing?
I'm sending this to I'm sending it to you.
Are you really gonna open Discord publicly?
What? Why?
Send it to like the main chat. You're gonna open your DM with Rory on the projector.
I don't use it. If I looked back, I don't think there's anything there. Oh, it's gone now. What is it? Jason sucks. Jason, what is it? It's just roasting you.
Alright, I think
Okay. Are we ready now? Yes, no, maybe so.
Oh, just kidding. Ignore that. Okay. We'll get to XSS later, but for now we're just gonna do a review of sorry. We're just gonna do a review of last week. Okay, so I think Laura went over this. So the client server model is basically how the internet works, right? So anyone accessing stuff is called the client, and then the things you're accessing are going to be held on a server somewhere. So there's this kid off the screen right now. We can call him Walter, and he wants to watch a YouTube video. So he's going to send a request to YouTube, and then YouTube's going to process that, and then in the back end, we'll pull up some video, like whatever he wanted, right? So this would be a GET request. I think you guys went over GET and POST last week. And then that's going to get sent back to Walter, and if he really enjoys it, then maybe there will be like further interactions. So like maybe I'll type something, and then that will get sent, for example, like as a post request and become a comment on YouTube, right? So that's the general like exchange back and forth. Like you send a request, get post, server does something with it, and you'll get a response. So for the purpose of this workshop, there's some more important details that are kind of left out of that. In terms of the context, right? So before you send the request, you're generally going to get it somewhere, right? Like you're not going to open up Postman, type out all the headers, all the information. Usually you're clicking on a link, doing it through some interface, right? So the response is going to be created for you somehow. So in this case, we could say like maybe he got it from someone emailing it to him, which is also off the screen, unfortunately. But yeah, that's one place where things could go wrong. Like if you get a bad request from somewhere and you send it, what the server does and what happens on your computer after that could go wrong because of the way the request was created. And then the other important detail is that it doesn't just get back to his computer, right? There's a bunch of raw data being processed. Code is running on his computer to actually make the request. And so as you know, like when code runs, malicious code can do bad things. So if somehow the server is returning malicious code, the malicious code will be running on his computer in his browser. So part of the importance of code running in your browser is cookies, right? So as we went over last week, cookies is like mainly your identification on the internet. So when you see ads for stuff that you've been looking at before, that's cookies, third-party cookies. Within a site, there's activity records through cookies. Usually that's like in the form of a shopping cart or something like that. And then there's also authentication, which is why on a lot of sites you don't have to log in every single time. But basically, the point of this is it's mainly for your convenience, but if someone gets access to your browser, say through malicious code, they have access to these cookies, which is like all of this. And then I don't believe you guys went over JavaScript previously. So basically, whenever anything interesting happens on a web page, it's going to be JavaScript, right? So clicking on a button, even if it doesn't do anything, loading cookies, sending requests between sites, that's all going to be JavaScript. And so it's important to know a few of the main ways JavaScript is used, right? So you could put it in just like HTML with these script tags, right? So the script tag essentially, like syntactically, makes it like there's no difference syntactically between this and HTML, except for the fact that within the tag it says script. You can also load JavaScript in from somewhere else, right? So within the script tag, you can say the source of the script is this other place, and it'll load the script in from there. And then also, without using the script tag, if you have something that generates an action, you say like when that action happens, the JavaScript will run. So in this case, it's saying like when we click this button, the inner HTML of this tag is going to change to the date. So like originally it would say time is question mark, but when you click on the button, time is would change to whatever date it is when you click the time.
Yeah, so first before we get into XSS, one important thing to talk about is the same origin policy. So this is like a really important security concept. Basically, scripts in one web page can't access data in another web page if they don't have the same origin. So this is important, right? Like say like you open a really suspicious website, you don't want it to like access stuff from like, for example, if you have like your banking site open in another tab, you don't want those two things like interacting. And then basically what same origin means, is like they have the same schemes, like for example, HTTP versus HTTPS, hostname, or more commonly, I guess we call it domain. So like, for example, youtube.com, and then as well as port. And then the same origin policy only applies to scripts. So other things like images, CSS, whatever, all these can be accessed across origins. And then the thing about XSS is when there's vulnerability, this is when SOC can be bypassed. So what is XSS, or cross-site scripting? It's basically when an attacker is able to inject malicious scripts into a web application, and it's often in the form of JavaScript. Technically, like HTML is also like JavaScript is like the most common one. This is like a really huge problem, right? Because when you open like a website in your web browser, your web browser thinks it's a trustworthy site. But then because of the XSS vulnerability, the attacker might have like injected a malicious script into the site. And then what happens is that your browser ends up executing it anyway. This is actually like a really prevalent problem, especially like pretty much in any site or web application where users are like putting in input and then there's some sort of output being generated. So a lot of big tech companies like Google or whatever, all of them have had like issues with like XSS vulnerabilities, and they actually have like these things called bug bounties. So they basically invite people to like search for XSS vulnerabilities in their websites and then report it to them for like, I guess like cash prices basically. So there's two main different types of XSS. There's a third one, but we'll go more into that later. So the two main types are reflected and stored. Reflected is basically when like a web application, it takes in some sort of input from the user, and it doesn't really like process it much or like sanitize it much, and then like it immediately echoes whatever the user inputted back into the web application. So this is like a really big problem is like the user input, aka the attacker, for example, constructs some sort of URL. for a user to execute in their own browser. So a lot of times you might see some sort of like parameter in your URL. And if the user like opens that URL, for example, and then there's something bad that the attacker put in the URL, it like executes in your browser, and then like now the attacker has access to any sort of like private info they have. And then the other type of XSS is stored XSS. So this is basically when the script is now stored in the website. So this is like commonly seen like in the form of like forum messages or like forum posts as well. And then what happens is that any visitor to the site, they may like unknowingly interact with the code, and then that ends up executing the script inside of their browser. So here we have an example of reflective XSS. So on the left side is like normal, like everything is fine. So it's like a little hard to see, but like if you look at the URL, you see that after the Q equals is here, I mean that's not my help. And that basically comes from like what the user inputted into the search bar. And then you can also see that that has also been echoed back into the web application. So there's sort of like this kind of relationship. On the right is like sort of it's like where there's an issue with the XSS. So this is like a real world example with Uber during 2016. So they didn't like sanitize the input that the user put in. And then now that the input has like a payload, when the URL is executed in the browser, now there's like it's possible for the attacker to like run like an alert message in the user's browser. And in stored XSS, there's an example of Samy word. So this is like a very well-known example. So basically what happened was that, sorry, forgot his name, but the person who developed this word, what happened was that he wrote a payload in his MySpace profile page. And then basically what this payload included was that it displayed a message. So as you can see, so most of all, Samy is my hero. And then it also had JavaScript code that basically made the victim, like, so whoever viewed his MySpace profile page, made the victim send Samy a friend request. And then it replicated the payload in the victim's own profile page. So what happens is that now that the victim has it in their profile page, so anyone who sees their profile page, the same thing happens to them. So over 1 million users fell victim to this virus within like 20 hours. So this is technically like the fastest spreading virus of all time. And on a side note, although this is like relatively harmless, the person who designed this, his name was Samy. He was raided by the U.S. Secret Services. And according to him, he ended up being sentenced to 3 years probation. He only had access to one computer, no access to the internet. He needs a community service, and 15 to 22,000 US dollars in restitution. So don't do it.
You're cool enough. That could be you.
Okay, this is like the third type of accesses. Depending on like who's defining it, like this may or may not be like a third category, but it's definitely very important. So this is what happens when an attacker injects the malicious payload into the web page during runtime. So in this scenario, like the HTTP response it isn't effective, which is what like a lot of stored and reflected XSS can do. So this is possible when like the JavaScript on the user's end is like problematic. Basically, if the script takes in data from some sort of untrusted attacker controllable source, so for example, the URL, and then takes that data and puts into a sink that supports dynamic code in the DOM. So for example, the HTML document. So then it's very easy for an attacker to inject like malicious code and then execute it without like ever like doing anything to the HTTP response. And this is just all because of problematic JavaScript. So here I have some of like the main things that can lead to DOM XSS vulnerabilities. So like document.write, element.inner HTML, like these are all pretty problematic in that aspect.
Okay, do you want me to stop sharing my screen then?
Yeah.
Well, what do you mean you can do it?
Or no, I'll try.
What?
Wait, just plug it into your computer.
Oh,
You have to enable screen sharing.
Oh, no, I can't screen recorder.
Get off that wire.
Don't tell me what to do.
all right, that's okay. I go for it.
Oh, secure.
Just so I'm gonna give a demo of stored XSS. And the best part about this demo is you can actually join live if you want. Oh, on Zoom, okay.
I allowed it. This is art.
All right. But yeah, okay, so you can follow along with this demo if you want. So you can just go to this link.
How they can follow along. Oh, you are? I thought you were
Follow along.
Yeah, I know. I was gonna set up a subnet, but I didn't. So you're just gonna have to go on the port.
Just send it in the Discord.
I'm trying.
Wait, it's just acmcyber.com :
Yeah.
1019.
Yeah, you don't need to go to this like the extension. You just need to go to this. So I'll leave it up there for like
I'll read it out to you guys. acmcyber.com:10019. Then hit enter.
all right, and then yeah, when you go to it, it will give you just like a random page. So but yeah, so
Wait, did everyone get that who needed to?
all right, so this is just kind of a quick overview of the attack. You don't need to understand this right now. I'll go back over it afterwards. But the basic idea of the attack, as is the case with most stored XSS, is that some attacker is going to basically like inject like malicious code into this page, and then what happens in just most XSS scenarios is that basically then at another point another user is going to go to the same page and they're going to download like the script which has been embedded in the page. So that's just like a high level overview, but I'll go back over this after I show you. So if you look at this site here, it has like an input box where you can just put in a message and then your name, right? So for example, I can say like hello and then my name, right? So if I do this, it will put the message up on the board, right? And everybody has like a unique board. So like you're not going to see my message right here, but if you add a message, you'll see it. And pretty much it just shows the date, the content of the message, and then the author. So what's happening here is basically you're just giving some text, and then the text is being uploaded to the server. And once the text is uploaded to the server, it's stored in a database. And then the next time somebody with this exact link, the one that I have up here, goes to this page, it's going to download all of the text that's been stored in the database, and it's going to render it on the page. And it does this by literally injecting the text that everybody has typed directly into the document object model, and basically wrapping it with HTML. So in a lot of cases, that would be fine, right? You can type a lot of things here and no problems will show up. But the problem is that with HTML, the JavaScript code, which has been mentioned before, is actually like wrapped within the HTML itself, which means that if you have like some script in your HTML page, it's actually going to run the script when you render the page. So for example, like this message, right? It can just be plain text, but I can actually put other things in it that are not plain text. For example, I can put in like any HTML element that I want and it will render on the page. So does anybody have like an example HTML element they want to see up there? Or... All right, yeah, I can do an image. I mean, an image might be, I might have to like pull up a link, so I'll just do a button for now, but I can do an image after if you want. So, all right, yeah. And yeah, so you can just kind of see like, right? And so it kind of shows a button here, right? And then like, yeah, I can get an image as well. So, right, so.
Oh yeah, I like that image.
So you just copy the link. And then for images on like the site, basically you just type image. This is how you type HTML, right? So yeah, so that should be enough. It should show up. And then yeah, you can see that just a random image appears. Oh, well, I mean, I guess I typed the link wrong, but that's, you can get the idea, right? Basically the idea is that if you upload actual JavaScript or if you upload actual like HTML code, it will be interpreted by the browser as HTML code, not as text. And like it's kind of interesting. Like in this case, nothing harmful is happening. There's just a button and like an image, but like the image is not like causing any harm. It's just kind of showing something that's not text on the screen. But as we've seen as people have mentioned before, you can see that there are other things you can do as well. So for example, you can put a script tag here, right? And this will just run the actual, like whatever JavaScript we put in between these two tags will actually be run on the page. So for example, we can type alert. This is pretty much the simplest JavaScript like command or JavaScript function. And it basically just like pops up an alert box on the page. So, so as you see, the page reloaded because I uploaded it. And now it's given me an alert statement. And the only reason this shows up is because the alert function was actually called by the browser. And anybody who goes to this link, like if I go to this link on another browser, it's going to do the same thing. And I'll show an example of that in a second. But oh, as you can see, somebody else has also done the same thing on this link. But yeah, so I'll kind of go over why this is important, and then I'll go over another example. So as you can see here, this is just pretty much what happens is that some malicious user is going to get the page. That's what the get slash is. So that request goes to the server and then comes back. And it comes back with clean HTML code. There's no script in there. There's no malicious code. But then what the malicious user does is they make a post request to the website. This is what happens when you press submit. And it basically uploads a message and an author. And in this case, they actually input like a script, like a pair of script tags and then some JavaScript. And then this goes to the server and gets stored in the database. And once it gets returned from the database, it's embedded in the HTML code that is returned to the user. That's why when you press submit, it shows the alert for you. And then some other user will go to the page later and basically they're going to call the same method, but it's going to return to them the same HTML that's wrapped in, or the same script that's wrapped in HTML. So basically anybody who visits that page from now on will get like whatever the alert text goes on. So this is bad because like this attack function, right? It can be replaced with any malicious code. It doesn't just have to be an alert statement, right? Alert is kind of like an innocuous thing, but it can cause major issues. And an example of that is what I'm going to show you next. So basically, I'm going to just get a new link so that there's no scripts on here. And yeah, so a problem with this is that since you have code running on somebody else's browser, what you can do is you can actually like steal some of the information from another user's browser, and then you can send it back to yourself. So the way that you do that is because there's a JavaScript function called fetch, and that function basically makes a network request to whatever server you want. So in our case, pretty much we can set up like a temporary server, also known as a webhook. And this is just basically going to give us a link that we can send requests to. And if we embed that in our payload, then anytime the code runs on a victim's browser, it's going to send the whatever we want to that webhook. So you can set up a webhook by going to this website called where is it? It's called webhook.site. So if you go to webhook.site, it will generate a link. So for example, Okay. Also, I opened in a private tab so you can see it's like a separate browser. But
Oh.
so it will give you like this is the webhook, right? This is the link. So if any requests that go here will show up on the left side. So I'm just going to copy the link. All right, and then so this time my payload is going to be more dangerous. So I'm going to type script. And then in here, I'm going to type fetch, right? So you don't fully have to understand the syntax right now, just you just need to understand what's going on. But the first parameter is just the link that you want to send to, which is the paste or the link that I just pasted. Okay. And then the next thing is an object that takes 2 arguments. In our case, we're just going to say method post and then body. And then I'm just going to say hello as a test. Okay. And so this payload, right? It's in the slides, by the way, if you want to see it for the rest of it. But this payload, when it runs on a victim's browser, what should happen is the victim's browser will call this function and it will make a request to webhook.site, and then it will send a post or it will send a post request to this site, and it will attach hello to the body of the request. So it's easier if I just show you what happens. So yeah, as you can see, people have been messing with the site, but so it should have made a request. As you can see here, here's what happens, right? So it did make a request to this site, and if you look, the content says hello, which is what we put in our payload. So now, for example, let's see what else we can do, right? We just sent hello, but you can call any JavaScript on this page. You don't just have to send a random string. So an example of this is you can send your like the cookies of whatever like browser it's running on. So the way you access cookies is by using document.cookie. And cookies are really important because they, as was mentioned before, they can kind of like store login information. So if some like admin were to run this site, you could potentially steal the admin's cookies, which would allow you to log in as an admin, which that's basically like one of the worst things that can happen when you do this. So and so in my case, there shouldn't be any like interesting cookies. There might be, but let's find out.
Where can we find the slide?
Are the slides on Discord?
Let me just send a link in the Discord.
So in my case, there's no interesting cookies, right? As you can see, it's kind of said. Okay, I just want to make sure I typed the right thing as well. But yeah, so I believe I typed the right thing, but it says there's no content in here, right? So that means that my so my document .cookie is empty, right? But if I now open this on another browser, right? This website. So first, let me just add a cookie to here that could be like interesting. So you can open the developer tools. This is the same thing as like Chrome developer tools. It's just slightly different, but and then I can add a cookie if I want. So let's see. Where's the parse? So I'm going to make a cookie called flag, and then I'm going to give it a value of flag. Wow. And so now my browser is storing this flag. But in general, this could be where some like login information can be stored. And so if I go to this website with that cookie stored in my browser, it should run the fetch command or the fetch function, which will then send basically all the cookies in my web browser to my webhook. And my webhook, as you can see, it was sent here. And wait, is it this one? All right. So I'm pretty sure I typed in the payload wrong. So let me just try that again. Or let me just type in the one from the slides. All right. So yeah, this payload looks good. Interesting. Is it like per page? Oh damn. Yeah, let me try setting it here. Yeah, exactly. So yeah, sorry, I did not realize this is the case, but basically you have to set the cookies like on each page. I thought it was just like for your whole browser, but in general, you can change it here. I don't know, it's still not sending it, but
I think it's wow.
okay, there it is.
Oh.
Value.
What is going on here?
Are you getting other people's cookies?
I think so. I think a lot of people are like adding scripts here.
Flag value. No, below that.
Oh,
Yeah, let's double down. Working.
oh, sorry, I went to the wrong site. What is going on? Okay, I'm gonna open up a new webhook. Yeah,
Everything's reloading.
bruh. Can you guys stop XSS attacking my page, please? Okay, I'm gonna paste it really fast before anybody steals the link again.
That's so ominous. It's running. Like it brain better.
Okay, well, yeah, I mean, it's not seeming to work. It should work. Maybe it's a mixture of I probably just need to like reload something, but basically like you can see like in this case, like it did send a cookie here. It's just it wasn't the cookie that we had set in our browser because there was two of them set. But yeah, you can kind of see maybe somebody can guys work on there as like a demo, but yeah, also as you can see, a lot of people are going to my site right now, which is why there's so many different ones. Okay, I'll do one more try because now nobody's stealing here. Oh, there's a missing bracket there. All right. And then if the cookie is set in this browser,
That's going to be like basically.
All right. Okay, this time it should work. There we go. Okay, so yeah, you can kind of see how it worked. Yeah, as you can see, it was a little bit, there was a little bit of trial and error, but in general, it should work. You should get a chance to try and do it on your challenges. So I'll just kind of go over a couple other slides on XSS. So kind of we already went over this a little bit, but what are some implications of XSS, right? Like, other than kind of what I just showed you. So as I already mentioned, data theft. So yeah, you can use the fetch function and it allows you to steal cookies. If somebody's stealing like JWT tokens or like session tokens in their local storage, you can do like a similar thing. Same thing with files, but we'll go over that in a little bit. And then same thing with like browser hijacking. So you can, as you saw before, somebody changed my page so that it would go to a YouTube video. You can redirect like where the site goes. So that site is like a trusted site in this case. But for example, like if there was like an XSS vulnerability on YouTube, then and somebody put like an XSS payload in like a comment, then when you loaded the YouTube video, they could actually like redirect you to like a similar version of YouTube that's not actually YouTube. And then it would allow them to do things like phishing or other things like that. And then this one is like not as big of a deal, but I have seen it brought up in the past, is that you can actually do content spoofing, which is where you change what is like on the page. Also, same thing kind of happened in the demo. That was kind of unintentional, but I mean, it worked. And you can kind of see like an example is you could send somebody a news article from like a trusted news site, and then you can actually like change what the news article says. So you can send somebody a news article like from a trusted site, and there's no reason for them not to believe that what the article says is not true. And then you can just completely change everything on the site as soon as it loads on their browser. So that's another example. And then yeah, I kind of already went over all of this stuff, but you can use webhook.site to set up like a temporary webhook. And then this is like the payload that I used, but this is like a pretty simple payload, and this might come up in the challenges. All right, so then let's kind of go over a little bit about prevention, and this is also applies more broadly to just any type of injection attack. So next week we're going to be going over SQL injection, but this is kind of like there isn't a lot of ways, as Michelle mentioned, like there's no way for the browser to know whether or not the code is like clean or not. So what we kind of have to do is we have to try and filter out like anything that goes into the server. So for example, if I tried to type something into the text box that I was on my site, I could basically like search the site and see maybe, is there anything that says script, or are there any HTML tags? And like, basically if there are, then just like filter them out. But this is actually a little bit easier said than done, because I would say like a lot of people would probably see this filter and think that it's actually secure. I know for sure the first time I ever learned about XSS, I saw this and I think, oh, well, I mean, what's the problem with this, right? Like you're just, if you see script, then you just remove it. And that's kind of like, as you see, like this script can be fooled by this, right? Instead of using like a script tag, you can use an image tag, or you can use another tag. So there's lots of different ways you can trigger these attacks. Like for example, this image is loading, and like when the image loads, it will run attack. And in this case, basically like if they say, okay, you're not allowed to use onload, then you can basically load an image that doesn't exist. And then when there's an error, it will call attack. So you can kind of like induce an error and then have it call like an error handler. But then there's even more ways you can do this actually. So for example, this script basically say it removes every possible like HTML tag, right? So in that case, like you'd think, well, how would I ever be able to write tags on the page if it removes all the HTML tags? Well, in this case, what's happening, the weakness of this is that it basically substitutes like each HTML tag for the empty string. So what you can do, and it doesn't call it recursively. So what you can do is you can actually embed your scripts within, or your tags within other tags. So what happens here is that this tag will be removed, and then what's left over after is like the actual tag that needs to be there. So there's actually a lot of ways you can do this. And like if you go on to this link, you can see more. And so to my knowledge, this is like one of the robust filters that you can write though. And this is like definitely primarily used as a server-side filter. And basically what this one does is it just goes through and anytime it sees angle brackets or anything that can potentially be used to induce XSS, it just replaces it with like its escape sequence. So if you don't know what these are, basically if a browser sees the and sign and then AMP, it just interprets it as the and sign. So like really in the code, it's this, but on the browser, it looks like this. So basically it will still look like there's a script tag there, but it won't actually be being interpreted as a script tag by the browser. And then if you want to learn more about this, if you're worried that your website might be vulnerable to XSS, you can go on this link and then you can find out more like ways to do this. In general, this is done automatically nowadays. Like even for my demo, like I had to like manually set a flag so that it would allow it to happen because it's so common. So in general, if you're using like a pretty widely supported framework for your front end, like you don't have to worry about this stuff. But you should definitely know it exists, and maybe you should worry about it if like your if your framework is kind of like old or yeah. And then you want
This is Jason.
okay. Then,
What is this in monospace font?
All right, so we're gonna do a quick aside on what CSRF is. So CSRF stands for cross-site request forgery, and it's basically when you make a request to another site from your site. And so remember we covered the same origin policy from before. You're not allowed to like view information on like another banking site that's not yours. Well, for a long time, there was sort of one way to like circumvent this, because while you could not get the contents of another site, you could still make requests to that site, and cookies for that site would still be sent along with the request. So if I were to make a request to like, bankingsite.com/pay, and I include the post parameters like 2 equals JSON, value equals $1 million, then the cookies for your authentication to the banking site would be sent with the request, and you'd pay me $1 million. So even though you can't get the response, it doesn't really matter because the money's already sent. However, this is no longer true because there's a property on cookies known as same site. And so the old default was same site none, which meant that they would be sent along with every single request. But nowadays, all cookies default to same site lax, which means that if you send them from a request originating from another website, they will not be sent. So now if you try to like make a request to a banking website, you will just get an unauthorized page because there are no cookies. That's it. Why did you change? Who changed it to a monospace font? Now the slide doesn't even work out because of
Wait, it's this computer.
yeah, but it looks like that on yours too.
So is this your arch limit?
No, yours looks like that too.
No, it doesn't.
It has the picture.
No,
Wait.
it doesn't. You're
No, it's not
gaslighting.
the next slide.
It was because she was doing the share screen.
I'll explain later.
Why does your
wait,
computer
just swap-
change the
swap the
default slide
computer.
font to monospace?
Sorry?
Swap the computer.
Yeah.
Oh,
Okay.
what?
It's the entire. Okay, whatever.
Does your computer like not have like an Arial font?
Oh wait, neither do wait.
No, no.
Mine doesn't. Mine
I-
has Arial, but mine doesn't
It's
have.
because my entire operating system has been set to this font. Because I personally prefer monospace font over everything else. So I don't know why everyone always makes fun of it.
All right. And now like another quick aside. Something that you might see in this workshop, and if you do CTF, is this thing known as an admin bot. So it's not particularly applicable to the real world, but it is very convenient for making challenges because it's basically a bot where you give it a URL to your exploit, and then it will open a browser automatically and like navigate to the URL and make sure that your exploit actually works. So it's basically the equivalent of like if we didn't have an admin bot, you'd have to like walk up to one of us and then we'd open the URL in our browser, right? So the admin bot just does that, but automatically. There's not much else to it.
Okay, now we'll get into local file. I guess you can't see it. That's an L. Local file inclusion, LFI. So that's the second half of cross-site scripting and LFI. So basically, LFI is local file inclusion. It happens when an application uses a file path as an input. So we see right here, this says HTTP vulnerable, but it has that question mark file equals abc.html. And this is usually in PHP-based websites. So as you can see here, we have PHP code saying file equals get, and then that page. So that's how it's used correctly. Well, not correctly, but this is an attack. But how can this be a vulnerability? So LFI used as an attack technique tricks a web application to expose files from their own system. So as we can see before, where it goes file equals ABC, we can replace it. So this can potentially lead to remote code execution if we actually say you can change it from going .. slash or .. slash and potentially traverse the file directory. But if you're actually able to upload code to the web server, you'll be able to execute your remote code if you know its location. And then this is done through the same HTTP request in the browser. So simple ways to execute LFI. So again, it's the local file. Here we have that same traversal, or you can potentially, if it's allowed, see the passwords by just simply going file equals. So traversing directories and exposing files, and then that remote code execution. But it takes place here in that HTTP. So how can you test this vulnerability? So when a function opens a file and includes it inside the web doc. So instead of having your PHP thing simply go file equals get, you can instead do some filtering and checking. So you can check if it has extra slashes or extra colons, or you can check when you're getting these files instead of just simply accepting whatever the user puts there. And just by like testing your own application and making sure that you're not able to traverse your file directories from your web server. And you can choose not to take any file names from the user, and that should clear that up. And then other ways to protect your web app. So by using databases. So instead of including files on your web server, you can actually get the files from your databases where a user won't be able to simply traverse your database. They won't have access to it. You can also, instead of doing that file paths, you can replace them with IDs. So obviously those IDs you can't change them. You can simply put the ID in and the ID equals the path name. And then server-side instructions. So servers send download headers automatically instead of executing files in the directories. And again, preventing file traversal and inputs from users will prevent people from simply just typing in equals and changing it to show up things on the web page.
We're gonna do a demo now. We should do it on
Do you want a monospace font or not?
Sure, let's go. Actually, it's a lot better to change the zoom now. It's fine. I can probably just do it.
Okay, what does that mean? What are you up
Just
to?
open a web page. Wait, what are your like 30 tabs?
I can't see tabs anymore. This is my work computer. I'm like, they're gonna fire me. Okay, here's Microsoft Edge.
I'm just Chromium based now, right?
I don't know
Yeah.
actually.
Actually, I just realized, the source code was on the slide. So we're gonna have to find that again. All right. So, let's just take a bit to read this code. If you're not very familiar with Python, I'll sort of walk through it. So, request.args is the query parameters. You might remember that from last week. And it gets the image parameter. And if there is none, it just defaults like default.png. And then it opens the file images / and then concatenates your supplied image, and then it just sends that to you. So does anyone have any ideas where this might go wrong?
very engaged audience. Arnav.
There's a file somewhere that I'm not supposed to see. I can't see.
Yeah, so if we go to the actual website, so you can see like you can view the images as intended, right? Like lemon thing, pucks, flag, arch thumbs, right? But who says that our file name just has to be like these image names, right? So we can go up a directory with dot dot slash, if you remember, dot dot means the directory above the current one, and it will just append this to the file. So you'll have like images slash dot dot, which will go back up. And now like you can do stuff like I don't know, get the source code, and you see here's the source code for the program. And one thing that I like to do to like test for LFI is one file that's on every Linux system is /etc/passwd. Also something to note is that when you're at the root directory, which is the topmost directory, dot dot just refers to the current directory. So you can really add like as many of these as you want to go up to the topmost directory. Like you don't need to know the exact number. And we'll just check this file, and you see it does exist, and it enumerates like every single user. It is not very practical because like it's just like these users come in like every Linux distro. But it's convenient in that it's a file that exists on every Linux system, so you can just, it's at a fixed path every time, so you can just, read it to make sure it works. Also something interesting is Linux sort of has this like everything is a file philosophy. So a lot of things that you wouldn't expect are accessible from the file system. Like if you check proc self cmd line, you should be able to view the command I use to run the application. If you go to proc self environ, you should be able to view the environment variables, and I guess hip just puts stuff in. Yeah, so you can see the environment variables in proc self environ. So that's cool. What? And then also I put a flag here because it's a challenge. So yeah, that's sort of how LFI works.
But you kind of don't have to know what you're looking for though. Is there some way to like list all the files in some directory?
That is the thing about LFI is generally you will not be able to list directories, so you will just kind of have to know what files to look for. So in this case, like etc password, proc self environ, proc self command line, these are all at like fixed paths on like every system, so you can just like test for them, and that's why they're convenient, and that's why I use them. For like figuring out where flag.txt is, I put it in the challenge description. You can't see the challenge description here, but it's there. So that's how you would know. But otherwise, generally, you do kind of just have to like guess important file names. There are some like really, really, really dumb systems where if you try to open a directory, it will give you a listing of the directory, but that's kind of rare. But I mean, if that happens, then more power, I guess. And
Is that like Smallbird's website or is that different?
Smallbird's website is run with a web server that intentionally does that.
Yeah, but there's no vulnerabilities. Like
yeah. So you would need to write like a web server that intentionally does a directory listing, but then also doesn't filter out directory traversal, which is like really dumb. So like, if like LFI is like, this level of dumb, having directory listing LFI is like, so it usually doesn't happen. And were there any more slides after this?
Yeah, there's some. If people are interested, I know Michelle already went over Sammy's thing, but wow, thanks for stepping on the slide. Okay, so yeah, does anyone want to hear a little bit more detail about what Samy did, or do you all want to start just working on the challenges?
I would love to hear more about what's happening.
Okay. So basically, as Michelle mentioned, it was like back in the days of MySpace, right? And so MySpace had some filters. So they would filter out most tags. So you definitely couldn't put a script tag in there. Probably not image tags, and definitely not any of these. You definitely couldn't put any triggers in there. The word JavaScript was filtered out, and then also escaped quotes, which is useful sometimes for injecting, as you saw with inserting the link for a fetch. Other measures they prevented, so in a direct sense, they prevented XML HTTP requests, which is like another way you can send HTTP requests between pages. And then they had basically an equivalent of CSRF. So right when you're about to post something, they generate a hash, and that gets sent to like a confirmation page. So if you don't have the hash they generated, then the post doesn't go through. Okay, so some tricks he used to get around these things are basically a lot of the time XSS can be browser based. So if you know like people are using a browser that is susceptible, or you just want to get the injection in on some browsers will allow JavaScript in CSS tags, which could be useful for some of the challenges, if it really comes down to that. Sometimes splitting keywords is allowed, also browser based. So like, for example, if you want to type in JavaScript, but it's been filtered out, Internet Explorer does read Java new line script as JavaScript, or you can split words in random places like inner HTML like this. And then to get around the same origin policy, he would reload his post in a different domain in the code, and then have it send from there. And then there's like some JavaScript escape functions that escape data so that it doesn't get filtered out, and it doesn't filter out everything you need. So sometimes you have to manually escape it. The link is his own write-up for the worm. So like he goes over everything he found one by one that was being filtered out and how he got around it. And yeah, so Michelle already went over all of this. Basically, if you viewed his profile and saw his post, it would add him as a friend, make the same post on their page, and then add to the end of the bio, but most of all, Samy is my hero. And then, of course, you know the results. So yeah, the challenges are up on our website. And I guess we have rules. Feel free to ask us for help. Yeah, and there should be pizza here soon too.
Oh yeah, unrelated, like web dev advice. If you have a database, make sure the database actually,
I don't know how things work.
saves the data to files on your file system. Otherwise, bad stuff happens. And in completely unrelated news, you have to recreate your account for ACM Cyber.com.